The innovation is the creation of a new AI software for data-driven materials discovery. And it's the result of many years of collaboration across the world in terms of ourselves in Cambridge, as well as national facilities in the UK and international facilities across the world from Australia, the US, and China. The aim of the research project was to use AI to speed up the discovery of new materials. And one of our biggest results was the discovery of a material that improved the performance of solar cells. Instead of creating materials from scratch, we used AI to mine millions of scientific papers to find molecules that absorb sunlight, even though these molecules may have been made for a completely different reason.
We built our own software because scientific articles use very specialised language, and that meant that at the time there were no real AI methods that could understand the text we were trying to process. We needed a model that could understand chemical terms and then be able to extract the information that we needed. And this started way back in 2011, so it really was like cutting edge at the time, and there was no chemistry aware AI tools that existed. We used the software to narrow down from the thousands of different candidates that we'd extracted down to just a few different options. We could test those out in the lab in real life solar cells instead of just leaving them on the computer. So AI combined with experiments has allowed us to find cleaner and more sustainable approaches than previous methods in a much faster timeline.
Recently, our team identified a solar cell material with an operational performance that reached around 92% of the industry standard. Critically, the material doesn't contain heavy metals, so it avoids the environmental concerns that are usually associated with these kinds of materials. As a group, we're now moving from the kind of static chemical databases onto question-answer style datasets for prompt engineering and also materials-focused language models. So then the next step would be closing the loop between the AI predictions and the experiment, and we can do that by linking up with automated or self-driving labs to speed up the experimental validation and then shorten the molecule to market timeline.
Collaboration has been critical to the success of this project, working with interdisciplinary teams to enable design-to-device materials discovery. So that's working with AI and data scientists to design new materials, to working with chemists to synthesize the materials, and then working with others to build and test these materials in devices. We're all working together to accelerate the discovery of sustainable materials.